Okay, so we'll finish up with the Velcro. So the Velcro strips that come in the kit, you've cut 1/2 inch off to mount your receiver, and that leaves the rest of the strip to mount your li-poly battery. Now, for most setups, your li-poly will go roughly in the center of the battery tray. If you look, the battery tray starts here at the back, goes all the way to the front. So this area over the landing gear mount would be the center of the battery tray. Most li-polys are going to mount in this area. Depends how heavy the li-poly is. The lighter the li-poly, the farther to the front it will go to balance your airplane. The larger the li-poly, the farther to the back it will go. So what we're going to do is we're going to install our Velcro over the center of the battery tray. It's self-adhesive, so we're going to stick it down to the center of the battery tray. Like so. We'll press it down a little bit. And then we'll take our thin CA glue and we'll put a few drops of CA glue, a couple in the front, a couple on the sides, some here at the back, and that'll just be a little bit stronger adhesive than the adhesive that comes on the Velcro. So we've placed a little bit of thin CA all around this Velcro. Now, when you put the opposite side Velcro on your li-poly battery and you stick the battery down, that's pretty secure, but it's not secure enough for really harsh aerobatic maneuvers. So we also include this Velcro seat belt in your kit. Okay, so you're going to want to remove the little bit of Velcro left in the end there, and what it does is it threads through itself and it forms a loop, and you press it down, and this is an extremely strong strap. What you do is take the strap and you feed it through the battery tray like so, and it comes up the other side. It's a two-handed job to get that through there, so I'm going to put the fuselage down. Okay, like so. And that's how the battery seat belt goes through the battery tray. Place the battery in and cinch this strap down, and that's what holds the battery in place. Now, later on, once you're absolutely certain what your final battery location for the center of gravity that you like to fly the airplane at is, I recommend putting a little bit of CA glue on the strap where it goes under the tray, and that way the strap won't move around and it'll make it easier to install your battery. For now, we don't know exactly where we're going to end up. Everyone's preference for center of gravity is different. We don't know if our battery is going to end up here or here, so let's leave the strap loose for now. Now, on an extremely lightweight battery setup, say a 1320 or a 1400 milliamp unit, you may end up with the battery inside the cowl. If you do end up with the battery inside the cowl, it can be difficult to get both hands around the strap to cinch the strap tight. But those very lightweight batteries don't require as much force to hold them in the airplane anyway. So what we normally do in a setup like that is we'll put the strap up in the front, and instead of trying to cinch it through, we'll just loop the strap over itself and press it down, just like that. So the strap's not cinched, but the battery is small and lightweight anyway, and it's inside the cowl. It's not going anywhere. So if you're using a larger battery, say 1500 and up, you'll most likely end up with the battery back here where you can see it when the canopy hatch is off. In that case, we recommend using the strap in a cinch. If you're using something very lightweight and you'll end up with the battery here inside the cowl area, then we recommend using the strap in an overlay like that. Still plenty strong for a light pack. Okay, so to complete the fuselage, we're going to have to install the cowl. Before we install the cowl, we're going to fire up the power system and check the rotation direction on our motor. Again, We want our motor to spin counterclockwise looking from the front, and so we have our transmitter on. We're going to take our li-poly battery and we're going to plug it in to our power system, and we're going to hear the arming tones from the ESC. 3 beeps to indicate that it recognizes the 3-cell li-poly battery, then low-high to indicate that it's armed and ready to go. Let's listen to that again, just so you get an idea what ESCs sound like. Most of them make tones very similar to this. Three-cell li-poly and armed. If you put in a 3-cell li-poly and you hear a different number than 3 tones, probably good to stop and check out and see what's going on with your battery or ESC. In this case, 3-cell li-poly, 3 tones, ready to go. So we're going to take our transmitter and we're going to throttle up. And it can be a little bit difficult to see which direction this is rotating with no prop on. Don't put a prop on. We don't want anything dangerous happening here on our workbench. The easy way to tell which way it's rotating is just lightly hold the motor shaft. And in this case, it's spinning clockwise. It's going backwards. So we need to reverse the direction. It's easy to do. We take 2 of these connections here on the motor to speed control, and we reverse them. Okay? And now it's spinning the correct direction, spinning counterclockwise. Alright? Now, this is done. I'm going to show you one more thing that will be useful to you in the future. I'm going to disconnect one of the motor to ESC connections. I'm going to show you what that looks and sounds like. Back and forth. Back and forth. The motor won't spin, it just vibrates back and forth. That's the look and the sound of the failure of one of these wires. If you ever have one of these wires pull out from a plug, or if you have a solder joint break or a wire break or something go wrong in this connection, this is what you're going to see in here. Back and forth with no actual rotation. Now, these plugs, the male bullet connector on the motor side, there's the male bullet connector on the motor side, and the female bullet connector on the speed control. If something's going to go wrong in your power system, it's most likely going to be one of these connectors. Over time, these connections get loose, especially with a lot of plugging and replugging. So if you ever see this back and forth vibrating motion instead of your prop spinning and you're wondering what's going on, you're probably going to have to take off your cowl and examine these connections. Odds are one of them has gone bad. Either it's loose or it's disconnected, something's happened to it. But now you know what it looks and sounds like. So if you see that again, you'll be able to instantly recognize it. The back and forth vibrating motion, you'll say, aha, only 2 of my 3 wires are making connection. I need to take my cowl off and find out what's wrong. So since we have the correct rotation direction, we can unplug our li-poly battery, turn off our radio, and we can work on installing the cowl.